Dear students, welcome to Electronic Devices and Instrumentation Lab. Today we will discuss center tap full wave rectifier. In the last video we have seen half wave rectifier. Now we will see full wave rectifier. There are two types of full wave rectifiers, center tap full wave rectifier and bridge rectifier. In this video we will see the center tap full wave rectifier. Why the name center tap? If you observe the diagram, here this transformer is center tap. Here in the center we have tapped and taken one terminal out. So center tap full wave rectifier, we call this as a full wave rectifier because both the half cycles of the input voltage waveform are rectified. In the last video, if you have seen, only positive half cycles were rectified. Now both positive and negative half cycles are rectified. Once again, rectifier is a circuit which converts AC to pulsated DC. Now the output voltage is continuous. Now here we must need a center tap full wave rectifier, center tap full wave transformer. Here is the AC input voltage 230 volts 50 hertz supplied from the government of Karnataka. Here this is the secondary winding. If you observe, secondary windings are less than the primary, so it is a step down transformer. For the full wave rectifier, we need to rectify both the half cycles, so we require two diodes D1 and D2. Here is a load resistor. If you remember, half wave rectifier used only one diode, full wave rectifier needs two diodes. In one half cycle D1 conducts, in the another half cycle D2 conducts, so both the half cycles are rectified. Here we have not used any filter, no capacitor filter, so ripple factor, the theoretical ripple factor, you will get it as 0.48. Suppose if you use a capacitor across the load, this is center tap full wave rectifier with capacitor filter. The same circuit, only the difference is the capacitor is connected across the load. If you connect the capacitor across the load, just observe the output voltage waveform, observe the output voltage waveform, you will get almost a straight line, Now see in this picture, later we will see in the CRO. So you don't get this pulsated DC, but you will get this output voltage waveform where the ripples are almost removed. Now coming back to the hardware circuit, what you are observing is a center tap transformer. Here we apply 230 volts AC 50 hertz. Here center tap 909. Here if you measure 9 from here to here 9. This is a center tap where you will get 0 volts. So this center tap transformer gives you 90, here 90. For center tap full wave rectifier, we must need a center tap transformer. Here we have used two diodes. And a load resistance. Now let us see the input voltage waveform. How it looks in the CRO. Here is the input voltage waveform. What you can see is a pure sinusoidal waveform. Now let us see the output voltage waveform across the load. This is input. This is center tap full wave rectifier. Both the half cycles must be rectified. Let us see how we will get the output voltage waveform. Now you can see earlier it was sinusoidal waveform. Now you are getting only positive half cycles, unidirectional. So this is the output of the center tap full wave rectifier without capacitor filter. Now here is a capacitor. I will try to connect this capacitor across the load. This is the output voltage. You can see almost pure DC. Keep looking at the monitor. Now I will remove the capacitor. This is the output voltage of a center tap full wave rectifier without capacitor filter. Keep looking at the monitor. Now I will connect the capacitor. See the change, the ripple, unwanted AC component in the output of the rectifier is removed. Now let us try to measure the AC component and the DC component and try to calculate the ripple factor. Here is a multimeter. Let us calculate AC and DC. Now already it is in AC. Here V sinusoidal symbol. So now we can measure the AC voltage. Ripple factor is the ratio of RMS value of the AC component of the output voltage. So at output I will measure Just note it down in your notebook. 3.85 AC component. Now DC component, change this to the DC. This is DC. This is 7.76. So AC is 3.8. So if you calculate, you will get around 0.48. Exact value you don't get 0.48, around 0.49 or 0.5. Practically there will be a small variation. This is without filter. Theoretically 0.48. Now I will connect the capacitor and let us see how the ripple factor changes drastically. Earlier you have noted down AC and DC component values. Now I will try to measure AC component with filter. This is the value of AC. Now you can see what is the value of AC. Earlier it was 3 point something. Now drastically AC is reduced. This is a rectifier. AC is unwanted. So this has been removed, 0.07. But see the DC. See DC value has been increased, 11.92. If you calculate the ripple factor using the formula given in your manual, you will get 0.000 something. So that means capacitor successfully removes unwanted AC component in the DC output of a rectifier. This is about the center tap full wave rectifier. Thank you.